This extra example page was something that I'd written up last fall, and I found it and I thought, this would be a good thing to add in. And this was sort of meant to be something where it could be worked on in class, where like I was in there walking around too. But this has an awful lot of writing on the first page, so I put it in already because otherwise I think this video would take forever. And then I figured what I could do would be to maybe just kind of point stuff out and circle it in the wording while we were going through it. So this first one, we have a shipment of ball bearings where the customer wants the average diameter to be within 0.02 centimeters of 2.5. Otherwise, they're going to send it back and say this isn't good enough. So the customer inspects 100 ball bearings in the shipment, which have an average diameter of 2.485 centimeters. So what I'm thinking here right away is these numbers, so like the 100 ball bearings and the 2.485 centimeters, it feels like that should be something. And they are, right? They're inspecting part of the shipment, so then it kind of feels like, oh, well, a shipment must be everything. That must be all the individuals. And then that group of 100 would be our sample. And that's exactly where we end up, right? Because they're looking at 100 ball bearings to get an idea of what the entire shipment is like, because the shipment is so big that they can't inspect every single one. So yeah, the sample is the 100 ball bearings that they actually get information from, where here information is their diameter. And then the population is all of them, so all the ball bearings in the shipment, right? They're just taking 100 out of that shipment, looking at those, so that's the sample, but then the whole shipment, that's all of them. Then the 2.485, what's that? Well, that comes from the 100 ball bearings, which we said was the sample. And if it's a number that comes from the sample, that must be our statistic. And that's exactly what it is, right? So the statistic, 2.485 centimeters. Or if you want to write it out in words, you could and say it's the average diameter of the 100 ball bearings inspected. But since we're given that direct value, I think if you had to write these out, I would just go, yeah, it's that number, right? That's less writing. And then the parameter, that's really why I wrote this in parentheses, to kind of show, okay, if this is what it is for the statistic, and this is what it is for the parameter. One thing about writing out what the parameter is usually you don't actually know that number. So you have to explain it in words. And the things that you need to get in there are three things for the parameter. So what you need for the parameter, and I think this is worth me writing it out, is, and this isn't maybe the best way of saying it, but I think it's the easiest to figure out what I mean. So it's not super rigorous, but the type of number, by which I mean, like, is it an average or is it a proportion, right? What kind of number is it? You need to have a reference to the population, because the parameter is supposed to be a number that describes the population. And then the third thing that you need to get in there is, I guess, what you would call maybe the context or the specification part, right? So like the average what, right? Well, here it's the average diameter. So here, the type of number, right? That's the one, right? That's that. So I can kind of diagram this since I've got it in here. The population is all this, right? All ball bearings in the shipment. So there's the population, which really it's this whole phrase right here. And then the context or specification, the average what of all ball bearings in the shipment? Well, the average diameter. So that's that third thing. And when you write out a parameter, or I guess like in the homework, you don't write them out as much as you kind of pick them out of a lineup, right? Because it'll be a multiple choice question. You got to pick out the correct parameter. Those are the things that you want to look for. So the parameter almost always cannot be written numerically. I mean, maybe if you have a census, you can write out the parameter as a number. But other than that, if you're doing any kind of inference, you're not going to be able to, because you're going to have information from the individuals in the sample, but not from all the ones in the population. So those are the three things you want to look for. What kind of number it is. It's got to relate to the population, not the sample. And then that context or specification part. All right, next one. Bloomberg Businessweek subscriber study collected data from a sample of 2,861 subscribers. got two things: the average annual income of the respondents. So that means from each respondent, we must have gotten their annual income, and then they got all averaged together to get that 84,000. And then it says 49% reported having an American Express card. So the other thing that they're getting out of these individuals that participated is, do they have an American Express card or not, right? So two things, which you can actually see them right there, right? It's the two variables. But then the thing that's the red flag for, and I guess it says sample of 2,861 subscribers. So if you look right there, you go, oh, there's the sample, right? So I made it a little bit fancier, right? And I said subscribers to Bloomberg Business Week that were surveyed. If it was something like 2,861 Bloomberg Business Week subscribers, I think that's fine. Or the Bloomberg Business Week subscribers who were surveyed, I think that's fine too, right? I mean, there are a few phrasings that I think would be acceptable here, but they're pretty similar to each other. And then you say, well, if the sample is 2,861 Bloomberg Business Week subscribers, the population should be all of that type of individual, so all Bloomberg Business Week subscribers, right? Like usual, the sample is just a little piece of the population. Then number two, the two variables, we kind of already went through this a little bit, but annual income is one of them, right? Because they must have reported their annual income for the study to come up with this average value. And then in order to say this, they must know who had an American Express card and who didn't. So annual income is one variable. The other one is whether or not a subscriber has an American Express card, right? And those two we can then classify further, like are they nominal, ordinal, interval, or ratio? Annual income, I mean, it's quantitative, so you're probably thinking, well, it's either interval or ratio. And it's going to be ratio because the idea of zero, like that's a natural zero, right? It's when you don't make any money, you have an income of zero. And then if you think about like, well, does the idea of like double and triple and that kind of thing, does that work? Sure. If somebody made $100,000 in a year, then they made twice as much as somebody who made $50,000, right? So the idea of twice as much, that makes sense. And when that happens, that's when you have ratio data. Then the other one, this is just nominal because this is a yes or a no, right? Either they have an American Express card or they don't. And that doesn't have an ordering, right? It's either yes or it's no. And it's not that yes is greater than no or no is greater than yes or anything like that. It's just two categories and that's it. So that one's going to be nominal. Then this was tough to squeeze in because this was really set up for one of them and I did it for both. I didn't really have enough paper, but it kind of fits in here. So for annual income, we know what the statistic is. It's the 84,000. The parameter, if we go back up here, what's the 84,000? It's the mean or average annual income of the respondents, right? So the respondents would be the sample, so we just have to change it to the mean annual income of the population, which is all Bloomberg Business Week subscribers. So that's basically all I did here. So it should be mean annual income. I missed a word. So that really ought to be in there. And I guess I could add that in. So make it blue so it fits together. So mean annual income. There, that's better. Of all Bloomberg Business Week subscribers. And then for whether or not they have an American Express card, the parameter, then it's kind of long-winded. The statistic, notice I have it as 0.49 instead of 49%, because up here that's what it is, right? 49% report having an American Express card. So you can do it in percent form. Then I guess if you said the statistic was 49%, then here you'd say the percentage of all Bloomberg Business Week subscribers who have an American Express card, right? Since it's the parameter, the only thing you got to change is to make it relate to the whole population, all Bloomberg Business Week subscribers. Well, why did I write it as a proportion? It's because later, when we get into inference, it works a lot better if you do that. Like all the computations will work correctly if you change into proportion form, and that won't necessarily be the case if you leave things in percentage form. So I'm just being careful for stuff that we're going to do later. Calling it 49% and saying percentage instead of proportion It's not wrong. It's just that I'm trying to foreshadow stuff a little bit, I suppose. The next thing on the next page is identifying what type of variables we have, and then for ones that are interval or ratio, are they discrete or are they continuous? Okay, so first, number of pages in each of the books in the Barnes & Noble Top 100. I guess the first thing is you got this number of, and when you see that, you want to be thinking count, and count means discrete. Okay, so I think we got that part down, but then is it interval or ratio? Well, does doubling make sense, right? If you had a 500-page book, is that twice as long as a 250-page book? Yep, right? You have a natural zero, you can't have a book with negative pages, right? You don't have a book that's negative 163 pages long, right? That doesn't make any sense. So this is going to be ratio, but then to specify further, it is discrete, right? Because it is a count. All right, next one, high school class ranking. Anything that's a rank is ordinal, because ordinal, like order, right? Putting things in order. So when you think about it, you go, well, like differences don't really matter, right? Like if somebody is, third in their class and then somebody else is first, you don't say, well, 3 minus 1 is 2, so the difference is second in their class. Doesn't work. So it's not interval or ratio, right? Because the math stuff, like mathematical operations, don't work. But there is an order, so it's not nominal, right? So this one's got to be ordinal. Weights, that's a physical measure. So anything that's a physical measure is going to be ratio, and it's going to be continuous, right? So that's pretty quick, right? Like you couldn't have negative weight, right? You have a lobster that's 10 pounds, that's twice as heavy as one that's 5 pounds, right? So this one's going to be ratio and continuous, right? It's a physical measure, so it's continuous. Time required to complete a chess game, that's another one that's time works like it's a physical measure. So this is actually going to be another one that's ratio and continuous. And if you think about it, you can see the ratio. Oops, I missed a letter. I missed a U. But if you think about it, if you have a chess game that takes, 16 minutes, then that's twice as long as one that takes 8 minutes, right? So the idea of doubling works. And now I have the word spelled correctly. Marital status of nurses in a hospital. Well, it's not a number, so that should knock out interval or ratio. And there isn't a rank, right? There isn't one that's better than another. So this one is nominal, right? And then number 6, colors of automobiles. Certainly that's not interval or ratio, right? This isn't a number. And this isn't one that has an ordering, right? I mean, I guess people have personal preferences, but there isn't like a universal ordering, right? It isn't universally thought that red is better than blue or anything like that. So this is going to be nominal. All right. Then I think I got to scroll down. I'm running out of room here. There we go. All right. Capacity of college football stadiums. All right. Well, this is going to be ratio because you can't have a negative capacity, right? So there is a natural zero. And you go, okay, you have some giant one like, like U of A's or something, where who knows what that can hold, right? Probably like 80,000 people. And you go, yeah, compared to something that's maybe like in a smaller conference that can hold like 20,000, you go, well, 80,000 is 20,000 times 4. That's 4 times as many, right? So, right, doubling, tripling, quadrupling, those ratio ideas work. So this is ratio, but the capacity is a count, right? Like you always know what the next possible value is, right? After 40,000, the next possible capacity is 40,001, right? It's got to be a whole number of seats. So this is going to be discrete, not continuous. Because you could enumerate the possible values, right? You always know what the next possible value is. The next one is mean. Zip codes of cities in Arizona. This is a little mean. Because when you think, oh, zip codes, those are numbers. Yes, they are. But this isn't interval and this isn't ratio because none of the math works, right? If you subtract one zip code from another, you don't end up with a zip code as a result, right? You just have some number. So none of the math works. There's no rank. And this is kind of like Social Security number, where it's a number, but really it's just a label, right? It's a label that corresponds to some city, right? You see a zip code, you go, oh, that goes to this city, right? Like that's the sorting machine at the post office. That's what it does, right? It reads that first and goes, oh, this number has to go here, right? So really this one is just nominal, even though it is a number. Then scores on the math section of the general GRE. You can tell what I'm doing here. I'm trying to pick something that doesn't have a natural zero. And I have no idea where this scoring system comes from, right? Why would you ever pick this where the lowest possible value is 130 and the highest is 170? That looks so bizarre. That happened after I took it, but I've seen that before, and I thought, this is so hard to read. Why would anyone pick this? But anyway, that's what they picked. So you look at this and you go, okay, this looks like it's quantitative and differences would make sense, right? Because you say, if somebody gets a 165, then they did 5 better than somebody that got a 160, right? Okay, but there's no doubling or anything, right? I mean, because there's no zero. Like, what would someone doing twice as well as somebody else be? Like, how would that even be represented here? It's impossible to show that. So this is one that's going to be interval, not ratio. So I guess I can put that in. So interval, and then is this going to be discrete or continuous? Well, if you're not familiar with the GRE scoring, you do always know what comes next. It only gives you integer values. So therefore, this has to be discrete because the next possible value after 130 is 131. Then the next possible one is 132, 133, 134, and so forth. So yeah, that one's going to have to be discrete. Then number 10, I wrote in already, where we said temperature measured in Fahrenheit is interval, not ratio, because that's not a natural zero. And it's not a natural zero because you can have negative values. And you could make the exact same argument for Celsius, right? But you could also phrase temperature as an ordinal variable if you didn't use numbers, right? What if you just said the temperature is either hot or warm or lukewarm or cool or cold, right? Those aren't numbers, so you couldn't do any kind of mathematical operation. So can't be interval, can't be ratio. But there is an order, right? There is a natural order here. So that is ordinal, not nominal. And then this, I guess, kind of came up in the other video, the section 1.2 video. There is a way you can get temperature to be ratio, but you have to use the Kelvin scale. You have to use a scale that had an absolute zero. So I guess that doesn't have to be Kelvin, but that's the common one with the absolute zero, right? Because that's calibrated the same way as Celsius. But that would work, right? If you used Kelvin, then zero Kelvin is absolute zero. So then you could say, well, 400 degrees Kelvin is twice as hot as 200 degrees Kelvin. And then that actually does work and you get the ratios. That's not the conventional way of measuring temperature in everyday life. But, you know, if you're a scientist, then you're going to see it a whole lot more than everybody else, right? And there it becomes a conventional thing. But the important thing is that there is a way that you could rephrase temperature to get it to be a ratio variable.